Hey everyone, and welcome to the Deep Dive. Today we're going to take a deep dive into the world of software engineering.
All right.
We've got some really cool academic slides to go through covering all the core concepts. We're talking quality, we're talking security, even some project management strategies.
Yeah.
So if you're prepping for like a big meeting or just, trying to stay up to date in the field, or maybe you just love learning new things,
Or all of the above.
yeah, then you are definitely in the right place.
Absolutely. And what's really fascinating is that these concepts, they're not just for the techies anymore.
Right.
Software's everywhere, and understanding how it's built, um, that impacts all of us.
Okay, so our mission today is to really equip you with, like a solid understanding of these essential software engineering ideas. We'll keep it clear, we'll keep it fun, and definitely not a lecture.
Definitely not.
So first up, let's talk about quality.
Okay.
I mean, we all want great software, right? But how do we even define quality? It's a very tricky thing.
It really is. And philosophers and engineers have been wrestling with this question for ages.
Yeah.
Robert Pirsig, in his book, Zen and the Art of Motorcycle Maintenance, he said that quality is something you immediately recognize, but you can't define it.
Hmm.
It's kind of like, trying to describe the taste of water, right? You just know it when you experience it.
I love that. And it's so true because when we were looking at some articles from Computer World and Info World, they were talking about just like this epidemic of bad software.
Right.
The consequences, oh my goodness.
Mhm.
Lost work, corrupted data, customers are unhappy, businesses are failing.
Yeah.
It's a big deal.
It's huge. Yeah. And the impact is massive, right? Lost productivity, I mean, that can just cripple a business. Missed deadlines can completely derail projects.
Yeah.
And then that damaged reputation, really hard to recover from that. So we're not just talking about like a minor inconvenience here.
Right.
It's about real world consequences. Exactly. Exactly. Okay, so how do we actually get a handle on this whole quality thing? Is there a way to actually break it down to make it more concrete?
There is. Thankfully, there's a model by David Garvin, and he gives us 8 key dimensions of quality to think about.
Okay.
So, for example, we've got performance. That's about whether the software actually does what it's supposed to do. Like you think about a video editing app that keeps crashing, that's a performance fail.
Huge fail.
Right. Then you've got features. Features are about going above and beyond, like that surprise feature in your photo app that automatically removes backgrounds.
Right, and then there's reliability, which is huge. Like if your banking app keeps logging you out, that's a reliability nightmare.
Yeah.
And then there's things like conformance. So does the software actually follow the rules so it can work with other systems?
Right.
Durability. Can the software be updated easily without breaking?
Right. And serviceability. When things inevitably go wrong, how easy is it to fix? A software program that requires a complete reinstall for a minor bug? Not good serviceability. Okay, so we've talked about the ideal, but let's talk about the reality.
Yeah.
There's this idea of, like good enough software, especially for smaller companies or, projects where you have a really tight deadline. Is that ever a good strategy?
That's where it gets tricky.
Well,
While good enough might be tempting, it's a risky game, especially when safety and reliability are super critical. Imagine good enough software controlling a self-driving car
right.
or a medical device. It's just not an option in those situations.
Yeah, no, that makes sense. It really makes you think about the responsibility of the developers for sure. And we also have to keep in mind the cost, right, of fixing errors.
Right.
I mean, it's way cheaper to catch those bugs early on in the design phase versus later on when it's already been built. It's kind of like, trying to fix a crack in a skyscraper after it's already been built, right?
It is, exactly. The later you find an error, the more expensive it's going to be to fix. And the sad part is, poor management decisions, they can actually make this way worse.
Well-
Unrealistic deadlines, ignoring those potential risks, and just mismanaging changes, it can create like a downward spiral of quality issues.
So it really sounds like building quality in from the start is absolutely essential. You can't just kind of sprinkle it on at the end, right?
It's like baking a cake. You can't just throw in some quality at the end and hope for the best.
Exactly.
A well-defined software process, that's key, just like a recipe. And that process should include quality management, change management right from the get-go.
Okay, and just like a good recipe, we need clear instructions.
Yes.
Vague requirements lead to confusion, frustration. You've got to have those clear, quantifiable requirements. It's like telling the baker exactly how much flour and sugar to use. No room for interpretation.
Absolutely. Now, if we want to talk about catching errors early, there's a really powerful tool called a formal technical review, or FTR. It's like having a team of experts reviewing the recipe before we even start baking. They're going to scrutinize that design. They're going to identify any potential problems before they become major issues.
So FTRs are like a quality control checkpoint for our software recipe. What does that process actually look like?
Think of it as a structured meeting. You've got the person who created the work, you've got the reviewers, and you have somebody there just taking notes. And the goal is to find those errors in logic, functionality, implementation, making sure everything lines up with those requirements.
That sounds pretty thorough for sure. Are there some maybe less formal ways to catch errors, earlier in the process?
Absolutely. Think about things like informal reviews, maybe like desk checks or pair programming.
Right.
Pair programming is kind of fun. It's like having a baking buddy. You're constantly reviewing each other's work as you go.
It's like a built-in quality control partner.
Yeah.
But how do we actually know if all these reviews are working?
Well, that's where metrics come in. So we can track things like how many errors are found per, unit of work, or how much effort is saved by finding those errors early. And actually, in our source material, there was a great example. They found that one team, just by finding requirements errors early, they saved 660 person-hours of testing.
Wow.
Yeah.
That's a big, big win.
Huge.
Okay, so that really highlights just how important it is to catch those things early. Now, speaking of making sure we have quality, what about software quality assurance, or COA? How does that fit into all of this?
Think of COA as the guardian of quality throughout the entire software development process.
Okay.
They set the stage and make sure everyone is playing by the rules. So they create an SUA plan that's kind of like the roadmap for quality.
Okay.
It outlines evaluations, audits, standards, and all those reporting procedures.
That's a big job.
It is.
What else does the COA team do?
So they review that whole software process, make sure it aligns with the established standards and policies. They're like the recipe testers, right? Making sure every step is followed correctly. And then finally, they conduct audits of the work products, making sure they adhere to the defined process. They're kind of like the quality police, making sure everything is up to snuff.
I like that, the quality police.
Yeah.
Okay, so ESQA really sets the stage and kind of keeps everything on track for quality. But what about actually testing the software? Isn't that where we really see if things work?
Oh, you're absolutely right.
Yeah.
Testing is where we put that software through its paces. But it's really important to understand how testing actually works alongside those other practices, like the technical reviews.
Okay.
It's kind of like, testing reveals whether our carefully crafted recipe actually results in a delicious cake, right?
Right. I love that analogy.
Yeah.
Okay, so let's talk about the different types of testing. How do these all kind of work together to make sure we've got a quality product?
So you can think of testing as having different levels, right? Each one with its own focus. First, you've got unit testing. And that's where we rigorously test each individual module or class. It's kind of like testing each ingredient separately before combining them in the cake.
Right.
So we're checking interfaces, data structures, boundaries, error handling, everything.
So unit testing is like making sure each ingredient is perfect before we even start baking.
Exactly.
So what happens after we've tested all those individual parts?
Well, then comes integration testing. That's where we put the pieces together and see how they actually interact, like combining our ingredients and seeing if they work together harmoniously.
Right.
Now, there are different ways to do this. We could go for the big bang approach, integrate everything at once.
Okay.
Or we can gradually add components, kind of like, slowly adding ingredients to a mixing bowl.
It's like making sure our cake batter is nice and smooth.
Right, exactly.
But the testing doesn't stop once we've integrated all the components.
Right. No, absolutely not. Regression testing, that is crucial.
Okay.
That's all about rerunning tests after we make changes to the software. So we want to make sure that no unintended side effects, have crept in.
Yeah.
It's kind of like tasting the cake batter after each edition, just to be sure we haven't messed up the flavor.
So we're constantly checking and rechecking to make sure everything's still delicious.
Exactly.
Okay, so are there any other types of testing that are commonly used?
Oh, absolutely. Smoke testing.
Yeah.
That's a quick way to identify any major showstopper errors.
Mm-hmm.
The ones that could derail the project.
Yeah.
It's kind of like checking if the oven is working before we even start mixing the batter.
Right, so making sure we have the right tools for the job. What about, object-oriented programming? How does testing work when the unit is a class instead of a module?
Great question. So in object-oriented testing, we shift our focus to classes and how they interact with each other. So you've got your unit testing, that's checking each class. You've got integration testing, that's making sure they communicate effectively, kind of like making sure that our ingredients not only taste good individually, but also complement each other in the cake.
It's all about creating a symphony of flavors.
That's right.
Now, what about testing specific types of applications? So like web apps and mobile apps, I imagine those have some unique challenges.
You're absolutely right. Web applications with their client-server architecture, you've got different browsers to deal with. They require a whole bunch of different testing, right? We got to consider content, databases, the interface, usability, navigation, configuration, security, performance. It's a lot.
That's a lot to think about. What about mobile apps? What are some key areas to really focus on when you're testing those?
So with mobile app testing, you really want to focus on that user experience across a bunch of different devices and network conditions. So you've got to consider device compatibility, performance under different networks, and of course, security, protecting that user data.
It's like making sure our cake looks and tastes amazing no matter what oven it's baked in
Right, exactly.
or who's eating it.
Exactly.
Okay, so speaking of different types of testing, you mentioned high-order testing earlier. What does that actually involve?
So high-order testing, that's where we focus on the big picture, making sure that the software actually meets those user requirements, integrates well with other systems, and actually performs well in those real-world situations. It's kind of like the final taste test of the cake, right?
Yeah.
Making sure it lives up to all our expectations.
So making sure the cake not only looks and tastes good,
Yeah.
but also serves its purpose.
Exactly.
Wow.
So, validation testing, that's where we check if the software meets user needs. System testing, that's verifying the integration of all the components. Then you've got your alpha and beta testing, which is all about getting feedback from actual users.
It's like having a focus group for our cake. Okay, are there any other specialized types of testing that we should be aware of?
Oh, absolutely. You've got recovery testing. That's where we actually intentionally make the software fail, see how gracefully it recovers.
Oh, wow.
Right? Imagine accidentally dropping our cake and seeing if we can salvage it.
Right.
Then you've got security testing. That's critical, right? We're actually trying to break into the software, find those vulnerabilities. It's like making sure our cake is safe from, any hungry ants trying to steal a bite.
Okay. It's all about protecting our precious creation. So what about performance and stress testing?
So performance testing, that's all about checking the software's runtime performance. We want to make sure it's quick, efficient, like making sure our cake is baked to perfection, not undercooked or burnt.
Okay.
And then stress testing, we push that software to its limits. We want to see how it handles those extreme conditions.
So we're really putting our cake through the ringer, so to speak.
We are. We want to make sure it can withstand a bumpy car ride.
Exactly.
Now, of course, despite all of our best efforts, what happens when those inevitable bugs, they just creep in?
Yeah, they always seem to find a way, don't they?
They do.
So what do we do?
Well, that's where debugging comes in. It's like being a cake detective,
Okay.
Tracking down those pesky bugs and figuring out how to fix them.
So how does this cake detective actually work?
Well, first, we got to reproduce the error, like figuring out exactly which ingredient caused the cake to crumble. Then we got to locate the source of that error, like was it a faulty oven or did we measure something wrong?
Right.
And finally, implement the fix. So adjusting the recipe or our baking technique to make sure we get a flawless cake next time.
It's like a culinary CSI episode. Okay, so we've talked about testing and debugging. Now let's move on to security engineering. Why is this so crucial for overall software quality?
Well, security engineering, it's all about building those digital fortresses that we talked about earlier. We want to protect our software from those who might try to exploit its weaknesses. Just like protecting our cake from those hungry ants.
Okay, so how do we actually approach security engineering? What are some of the key concepts that we need to understand?
So security engineering is all about understanding those potential threats, identifying any vulnerabilities, and then implementing controls to actually mitigate those risks, like installing alarms, locks, and maybe even some guard dogs around our cake.
I love that analogy. Can you break down some of the key terms that we should know?
Sure. So think of assets as anything valuable that needs to be protected.
Okay.
So this could be sensitive user data, system resources, even the software itself.
Got it.
Then you've got exposure. That refers to the potential cost and the time required to actually recover a lost asset.
So it's about understanding what's at stake. Right?
Yes.
If someone breaks into our cake vault, so to
Yeah.
speak, how much would it cost to bake a new cake?
Okay.
Then you've got threats. Those are those potential dangers that could compromise our assets.
Right.
So think of a hacker trying to steal our secret recipe,
Oh, no.
right? Or a power outage that could ruin our cake. Vulnerabilities, those are weaknesses in our system that attackers could actually exploit. So like a loose window in our cake vault.
Right.
And then controls, those are the measures that we put in place to mitigate those threats and vulnerabilities. So like installing bars on the windows or having a backup generator.
So it's all about building a multi-layered defense system for our cake.
Precisely.
Yeah.
Now, one of the key steps is to actually conduct a security risk analysis.
Okay.
That's doing a thorough inspection of our cake vault, right? We want to identify potential weak points and figure out how to reinforce those.
So how do we go about doing a security risk analysis? What are the actual steps involved? Well, first, we need to identify the assets we need to protect. So that would be our secret recipe, our precious cake. Then we examine the architecture of our cake vault, understanding how all those components fit together, the walls, the doors, the alarms. Next, we actually decompose the application. We break it down into smaller pieces.
Okay.
So like analyzing each layer of the cake or each ingredient in the recipe.
It's like we're examining each slice of cake under a microscope.
Right, exactly.
Okay, what happens next?
Well, this is where we put on our hacker hats.
Hmm.
We identify and document all those potential threats that could compromise our assets. We're thinking like those hungry ants trying to get into our cake vault.
It's a game of culinary cat and mouse. What do we do with all those identified threats?
Well, we rate them based on their likelihood and their potential impact. So, for example, a power outage, that's less likely than someone simply trying to pick the lock on our cake vault. So we prioritize those most serious threats, right?
Right, so figuring out which ones we need to address first.
Mhm.
Which ones pose the greatest danger to our cake?
Exactly. And once we've identified and rated our threats, we develop a plan to actually mitigate them, right?
Yeah.
So this might involve implementing those controls to reduce our risk. So installing a stronger lock on that vault door, having a backup power supply for our oven, and maybe even hiring a cake security guard.
It's all about creating a comprehensive security strategy
Wise.
to protect our cake from those who would try to steal it or sabotage it.
Precisely.
Okay. So, speaking of safeguarding our valuable assets, that brings us to another really important aspect of software engineering: configuration management.
Yes.
Now, configuration management, that sounds kind of technical. Why should we care about that?
Well, configuration management is all about taming the chaos of change.
Okay.
It's about ensuring that we always have a clear understanding of what constitutes our software system.
Okay.
Its components, their versions, how they all fit together. It's like having a detailed blueprint of our cake vault so we know exactly how it's built, what materials were used, and how to make any changes safely.
It sounds like a lot of work, especially in the fast-paced world of software development where things are constantly changing.
It is. But luckily, we've got, well-established practices and tools to help us manage that complexity. A key concept in configuration management is the idea of a baseline.
A baseline, what exactly is that?
Think of a baseline as a snapshot of our software system at a particular point in time,
Okay.
like taking a picture of our cake vault after it's built.
Got it, yeah.
It represents a stable configuration of all those components, their versions, and any documentation.
So it's like a milestone marker in our software development journey.
Exactly. Baselines are essential for managing change because they provide that clear reference point, right?
Right.
So we're tracking progress, identifying any deviations.
Right.
They help us answer that question, what has changed since our last snapshot?
Right. That makes sense. So how do we go about creating these baselines? What's the process?
Well, creating a baseline, it typically involves several steps. First, we identify all those software configuration items, those SCIs, that make up our system. These are the individual components, like the walls, the doors, the alarms of our cake vault.
It's like we're taking inventory of all the parts that make up our cake vault.
Exactly. We assign them unique identifiers, we document their versions. This ensures we can always track back to a specific version if needed.
It's like giving each component a serial number and a person stamp.
Exactly.
Okay.
Then we establish relationships between the SCIs. We're documenting how they depend on each other. This helps us understand how changes to one part might affect other parts.
Okay.
It's like creating a wiring diagram, right, for our cake vault, showing how all the components are connected and how they work together.
Once we have all this information documented, then we can actually create a baseline by capturing the current state of all the SCIs and their relationships.
Yes.
And this baseline then serves as that reference point for any future development and change management. It's like taking a photograph of our cake vault, capturing its exact configuration at that moment.
You got it. And just like photographs, right?
Yeah.
We can create multiple baselines over time, document the evolution of our software system or our cake vault as it's developed and maintained. It's like creating a photo album,
Right.
showing how our cake vault has changed over time.
That's a great analogy.
Yeah.
And these baselines are essential for managing change because they provide that clear audit trail
They do.
of what has changed, when it changed, and who made the change.
Right.
They help us to understand the impact of those changes, ensure that we're always working with the correct versions of our software components,
Yeah.
and maintain the integrity of our systems over time.
Exactly. It's like having a detailed logbook for our cake vault, documenting every modification, every repair.
It sounds like a really powerful tool for bringing order to this ever-changing world of software development.
It is.
So we've talked about baselines. What are some other key practices in configuration management?
Well, you've got version control, which we touched on a little bit earlier.
Right.
It involves using specialized tools to actually manage different versions of our software configuration items, those individual parts of our cake vault.
Right, like having a time machine for our software. Can you expand on how that actually works in practice?
Sure. So those version control systems, they allow us to track changes, revert to previous versions if we need to, and we can even manage parallel development efforts without creating conflicts. They're essential for collaboration, allowing multiple developers to work on the same code base simultaneously.
It's like having a shared Google Doc for software development,
Exactly.
where everyone can contribute and see the changes in real time.
That's a great analogy. And alongside version control, you've got change control. This is where we establish a formal process for requesting, evaluating, approving, implementing, and documenting any changes.
So it's like having a quality control checkpoint for every single change made to our software.
Exactly. Change control ensures that every change is carefully considered, it's reviewed, it's tested before it's incorporated into our software system. It helps us to maintain that integrity of our software, prevent regressions, and just make sure that those changes are properly documented and communicated to everybody involved.
It sounds like a very structured and thorough process.
It is. A well-defined change control process is absolutely essential for minimizing the risk of errors and ensuring that changes are implemented in a very safe and controlled manner.
So we've covered baselines, version control, and change control. What are some other important aspects of configuration management?
Well, you've got configuration auditing, which is crucial. This involves regularly reviewing our configuration management practices and documentation to ensure they're effective and up to date. It's like having a building inspector come in and check that our cake vault is still structurally sound and meets all the safety regulations.
So it's like a quality assurance check for our configuration management processes themselves.
Exactly. Configuration auditing helps us to identify areas for improvement, make sure we're complying with any relevant standards or regulations, and maintain a high level of confidence in our configuration management practices.
Well, that was a fascinating exploration of configuration management. It's
Yeah.
amazing how something that can seem so, I don't know, mundane can be so crucial to the success of complex software projects.
It's all about bringing order to this often chaotic world of software development. By managing change effectively, we can minimize risks, ensure the integrity of our software systems, and ultimately deliver higher quality software to our users.
Well said. Now let's move on to a topic that's really at the heart of software development testing.
Okay.
It's where we put our code through its paces to make sure it can handle whatever the real world throws at it.
Testing is absolutely essential. It's the proving ground for our software, right? We put our creations through these rigorous trials to make sure they're robust, reliable, and ready for prime time.
It's like putting our software through boot camp, making sure it can withstand the most demanding conditions.
Exactly.
Okay.
And testing, it's an integral part of the software development lifecycle. From the very early stages of development all the way through to deployment and maintenance. It's not just something that we do at the end.
So it's not a one-time check, it's an ongoing process throughout development.
Precisely. Testing should be integrated throughout that entire development process, from unit testing of individual components to integration testing of larger subsystems, and finally, system testing of the complete software system.
It's like having multiple layers of quality control, making sure every single part of that software is working correctly.
Exactly. And there are many different types of testing, each with its own specific goals and techniques.
So let's break down some of those different types. What are the main categories of testing?
One of the most fundamental types is functional testing. That involves testing the software against its functional requirements, making sure that it does what it's supposed to do.
So like checking off a list of features, making sure they all work as expected.
Exactly. And functional testing can be done at different levels of granularity, from testing individual functions or methods to testing entire use cases or user stories.
Sounds very thorough,
It is.
ensuring that the software fulfills all its intended functions.
Yes. And then you have non-functional testing. This focuses on aspects of the software that aren't directly related to its functionality.
Okay. What are some examples of non-functional testing?
So that would include things like performance testing, security testing, usability testing, and reliability testing.
Okay.
It's about making sure that software is fast, secure, easy to use, and doesn't crash all the time.
Right. And it sounds like those aspects are just as important as the functionality when it comes to that user experience.
Absolutely. Non-functional testing is crucial for ensuring that the software not only is functional, but it also meets the needs and expectations of the users.
So let's delve into each of these non-functional testing types a little bit. What does performance testing actually entail?
So performance testing, it's all about measuring the software's responsiveness, its efficiency, and its resource consumption under different conditions. We want to ensure that it can actually handle the expected workload without slowing down or crashing.
It's like making sure that our software can run a marathon without getting tired.
Exactly.
Okay.
And we use a variety of techniques to simulate different user loads and scenarios to assess the software's performance under pressure.
And what about security testing? What's the main focus there?
So security testing is all about identifying those vulnerabilities that attackers could exploit. We want to make sure our software is like a fortress, resistant to any attempts to breach its defenses and compromise sensitive data.
So security testing is kind of like putting our software through a rigorous security audit.
Precisely. We use a combination of manual and automated techniques to probe for any weaknesses and assess the software's resilience to attacks.
Okay, and then what about usability testing? Why is that important?
Usability testing is all about ensuring that the software is easy to use and intuitive for its intended audience. We want to make sure users can easily navigate the interface, understand those features, and accomplish their tasks efficiently.
So usability testing is all about putting ourselves in the shoes of the user,
Exactly.
seeing the software from their perspective.
Exactly. We observe real users interacting with the software to identify any areas where the design or the functionality could be improved to enhance the user experience.
And lastly, let's talk about reliability testing. What's the purpose of that?
Reliability testing is about ensuring that that software is robust and can handle errors or unexpected conditions gracefully. We want to minimize the chances of any crashes, data loss, or other issues that could disrupt the user's workflow.
So reliability testing is about making sure our software is dependable
Exact.
and doesn't let us down when...
Doesn't let us down when we need it most. So we subject the software to all sorts of stressful situations and scenarios to really assess its ability to recover and maintain functionality even when things get tough.
It's clear that testing is really this multifaceted discipline, encompassing all these different approaches and techniques to ensure that our software is high quality and robust.
It is.
But with so many types of testing, how do we know which ones to actually prioritize and how to integrate them effectively into the development process?
That's a great question, and that's where a well-defined testing strategy comes in.
Okay.
A good testing strategy, it considers the specific needs and risks of the project, it allocates resources wisely, and it ensures that all the critical aspects of the software are thoroughly tested.
So it's not a one-size-fits-all approach.
Exactly.
Each project will have its own unique testing needs.
Absolutely. And the testing strategy should evolve as the project evolves, as new features are added, as risks are identified, and as feedback is gathered from users.
So it's a dynamic and iterative process,
It is.
just like software development itself.
Precisely. And a well-executed testing strategy is essential for building high-quality software that truly meets the needs and expectations of its users.
Well, that was a really insightful exploration of the world of software testing.
Yeah.
It's clear that testing is not just a checkbox to tick off, but really this crucial and integral part of the software development journey.
It is.
It's an investment in quality, in reliability, and in user satisfaction.
Absolutely.
It's about building software that we can trust and rely on.
Exactly.
And as we move forward in our deep dive, let's explore another crucial aspect of software engineering, project management.
All right.
It's the art of orchestrating all the moving parts of a software project and ensuring that everything comes together harmoniously and delivers a successful outcome.
Project management and software development, it's kind of like conducting a symphony.
Okay.
You've got all these different sections, each with their own unique instruments and melodies, and it's the conductor's job to bring it all together in perfect harmony.
That's a beautiful analogy.
Thank
So what are some of the key qualities that make for a successful software project manager?
Well, a successful software project manager really needs a blend of technical expertise, strong leadership skills, and a real knack for communication.
Okay.
They need to understand the technical aspects of the project, but they also have to be able to motivate their team and keep everyone on track.
So it sounds like a very demanding role, requiring a pretty diverse skill set.
It is, but it's also incredibly rewarding.
Yeah.
A skilled project manager can guide a team through those complexities of software development,
Right.
navigate all those challenges, and ultimately deliver a product that makes a real difference.
So let's delve into some of the principles and practices that underpin effective software project management.
Okay.
What are some of those key tenets that guide successful projects?
Well, one of the most important principles is recognizing that software development is a team sport.
Okay.
It's about fostering collaboration, open communication, and a shared sense of ownership among team members.
So it's not just about assigning tasks and managing deadlines.
No, not at all.
It's about creating an environment where everyone feels valued and empowered to contribute their best work.
Exactly. And another crucial principle is embracing an iterative and incremental approach.
Okay.
Rather than trying to build the entire software system in one go, we break it down into smaller, more manageable chunks, delivering value incrementally and adapting to feedback along the way.
So it's like building a house brick by brick, layer by layer,
Precisely.
instead of trying to construct the entire structure all at once.
Exactly. And this iterative approach, it allows for greater flexibility, reduces risks, and ensures that that final product aligns with the evolving needs of the users.
So it's a more agile and adaptable approach to software development.
Exactly. And another important principle is recognizing the value of data-driven decision-making.
Okay.
So we use data to track our progress, to identify any potential bottlenecks, to assess risks, and to make those informed decisions throughout the project lifecycle.
So it's like having a dashboard for our project, providing us with those real-time insights and guiding our course.
Precisely. And the data can come from all sorts of sources: our project management tools, our version control system, testing results, even feedback from our users.
So it's about harnessing the power of data to make more informed and strategic decisions.
Exactly. And of course, communication is absolutely paramount in project management.
Right.
We need to keep everyone informed. We need to facilitate open dialogue and ensure that information flows smoothly between all stakeholders.
It's like being the conductor of an orchestra, making sure that all the musicians are in sync and playing from the same sheet music.
That's a great analogy.
Okay.
Effective communication is crucial for building trust, for resolving conflicts, and for keeping the project moving forward smoothly.
So we've talked about the importance of teamwork, iterative development, data-driven decision-making, and effective communication.
Right.
What are some of the specific practices that software project managers use to bring these principles to life?
Well, one widely adopted practice is agile project management.
Okay.
Agile methodologies like Scrum and Kanban, they prioritize iterative and incremental development, close collaboration with users, and a real focus on delivering working software frequently.
It sounds like a very flexible and responsive approach to software development,
It is.
well suited for projects with evolving requirements or where close collaboration with users is essential.
Exactly. Agile methodologies embrace change, and they prioritize delivering value to the users quickly and iteratively.
Okay, and what about risk management? How does that factor into software project management?
Risk management is a crucial practice, and it involves identifying, assessing, and mitigating potential risks that could impact the project's success.
Okay.
It's about anticipating potential roadblocks and having plans in place to navigate them effectively.
So it's like having a contingency plan for those unexpected storms that might arise during our software development voyage.
Precisely. And risk management, it's an ongoing process throughout the project lifecycle because new risks can emerge at any time.
So it's about being proactive and vigilant in identifying and addressing potential challenges.
Exactly. And another important practice is quality management.
Okay.
This involves ensuring that our software meets the required standards of quality throughout the entire development process.
So it's like making sure that every brick in our software house is sound and meets the required specifications.
Precisely. Quality management encompasses a variety of activities, including defining quality standards, conducting code reviews, testing the software thoroughly, and gathering feedback from users.
It sounds like a holistic approach to ensuring that our software is built to the highest standards.
It is, and another important practice is communication management.
Huh?
This involves ensuring that information is flowing effectively between all project stakeholders.
So it's like making sure that everyone in our software orchestra is playing from the same sheet music and following the conductor's cues.
That's a great analogy. Communication management involves activities like holding regular meetings, using collaboration tools, and documenting key decisions and project artifacts.
So it sounds like effective communication is really the glue that holds the entire project together.
Absolutely. It's about keeping everyone informed, aligned, and working towards those same goals.
So we've covered agile project management, risk management, quality management, and communication management.
We have.
Are there any other key practices that software project managers should be aware of?
Oh, there are a lot of other important practices, things like scope management, schedule management, cost management, and resource management.
Okay.
These practices help us define those boundaries of the project, plan and track that timeline, manage the budget, and allocate resources effectively.
It's clear that software project management is this multifaceted discipline requiring a pretty broad range of skills and expertise.
It is, but by mastering these principles and practices, project managers can lead their teams to deliver successful software projects that meet the needs of their users and stakeholders.
Well said. So what are some key takeaways for our listeners, even those who aren't aspiring software project managers?
Software project management, it's more than just managing tasks and timelines.
Right.
It's about leadership, it's about communication, and creating that collaborative environment where teams can thrive and deliver exceptional results.
It's about bringing together the right people, the right processes, and the right tools to create something truly innovative and impactful.
Exactly. And it's an ongoing learning journey requiring adaptability, continuous improvement, and a real passion for delivering high-quality software that makes a difference in the world.
It really is. And as software continues to evolve and really just expand its reach, these foundational principles become even more critical. The world is increasingly reliant on software, and that brings, new challenges and new things to think about.
Right, exactly. Software isn't just, confined to our computers anymore. It's embedded in almost everything, our homes, our cars, even our healthcare. And as software takes on more responsibility, obviously the stakes get a lot higher.
Exactly. The concept of good enough software takes on a whole new meaning when we're talking about, self-driving cars or medical devices.
Right.
A minor glitch in those systems could have really serious consequences.
For sure.
So the demand for, robust, reliable, and secure software is only going to intensify.
Absolutely. Yeah.
So it's not just about getting the software to work. It's about ensuring that it works flawlessly and safely in every possible scenario.
Right.
That's a huge responsibility for software engineers.
It is. And that's why those core principles that we've been talking about, quality, testing, security, and that disciplined project management, those are more relevant now than ever.
Right.
They provide that framework for building software that, we can trust with our lives, literally, in some cases.
Yeah, exactly. Exactly. So what does the future hold for software engineering? What are some of the trends and challenges that will shape the field, moving forward?
Well, one of the most significant trends, I think, is the rise of artificial intelligence, or AI. AI is transforming so many industries already, and its impact on software engineering is, it's just beginning to be felt. We're seeing these AI-powered tools now that can automate tasks, they can assist with coding, and even help to identify and fix bugs.
Wow. That sounds incredible.
Yeah.
AI had the potential to really revolutionize the way we build software.
It does. It really does. But it also presents some new challenges too, right?
Of course.
We need to ensure that AI systems are developed responsibly, that their decisions are transparent, that they're accountable,
Right.
and, that they don't introduce any new biases or ethical concerns into our software.
Right. So it's not just about building smarter software. It's about building software that's ethical
It's
and aligns with human values.
precisely.
Right.
And another major trend is, the ever-increasing importance of cybersecurity. I mean, as our reliance on software grows, so too does the threat of cyber attacks.
Right.
Software engineers need to be even more vigilant about building secure software, anticipating and mitigating those potential vulnerabilities.
It sounds like security is going to continue to be a top priority for software engineers. What other trends do you see kind of on the horizon?
Well, the growing complexity of software systems, that's another major challenge.
Jay?
As software becomes more interconnected and we rely more on cloud computing, these distributed systems, the Internet of Things. I mean, managing that complexity becomes even more challenging.
Right. So software engineers will need to develop, new skills and approaches to really effectively design, build, and maintain these, very complex systems.
Exactly. And we're seeing this rise of new methodologies like DevOps, which emphasizes that close collaboration between development and operations teams to streamline the software development process and deliver software more rapidly and, of course, more reliably. It's all about adapting to this evolving landscape of software development.
It's fascinating to think about how the role of the software engineer is constantly evolving. It's a field that really demands that continuous learning and adaptation.
It does, absolutely, and that's what makes it such an exciting and rewarding field to be in. Software engineering is really at the forefront of innovation, shaping the future of technology and ultimately influencing the way we live, work, and interact with the world around us.
As we wrap up our deep dive into the world of software engineering, I'm just really struck by the incredible impact that software engineers have on our lives.
Yeah.
It's inspiring to think about, the creativity, the ingenuity, the dedication that goes into building the software that powers our modern world.
It is truly inspiring, and I really hope that this deep dive has sparked a curiosity in you, to learn even more about this fascinating field. Whether you're considering a career in software engineering or just want to become a more informed user of technology, there's a wealth of information out there waiting to be explored.
Absolutely. Understanding these principles, the practices, the challenges of software engineering, it empowers all of us to make more informed decisions about the technology that's shaping our lives. It kind of gives us a peek behind the curtain and a deeper appreciation for the incredible work that software engineers do.
Well said. As we conclude this deep dive, just remember that software is all around us.
It is.
It's shaping our world in some really profound ways. And by understanding how it's built, we can better navigate this increasingly digital landscape.
Thank you so much for joining us on this deep dive into the world of software engineering. We hope you enjoyed the journey and gained some really valuable insights into this fascinating and always evolving field.
Until next time on the deep dive, keep exploring, keep learning, and keep questioning the world around you.